In this recording, we're going to look at graphs in polar form and rectangular form, and we're going to convert three polar equations into rectangular equation form to help graph them. So I'll give you a chance to write down this heading and this equation. Play the recording when you're ready. Okay, so hopefully you paused and wrote down that information. Next, what I'd like you to do is write down any conversion formulas you know. There should be 5. So pause. Don't look at any notes, write down as many as you know, and then look at your notes to figure out the ones that you omitted. Okay, so hopefully you took time to do that, and you came up with the 5 conversion formulas. Okay, now that we have those tools at our disposal, kind of written over in our margin here, we can see what we can apply here. We're trying to convert this r equals 8 secant theta into something with x's and y's, so we can graph it on the rectangular plane. So, well, I don't see anything with secant over in our formulas, but I do see something with cosine which is related. So maybe what we can do is rewrite this as r equals 8 over the cosine of theta, because that is the reciprocal of secant. Having done so, I see something with r in cosine. So if I were to multiply both sides by cosine to undo this division by cosine, that'll divide out. And on this side, I will have cosine theta. So r cosine theta I'm familiar with. That's one of my laws over here, my conversion rules. So on the left side, I've got r cosine theta, and on the right side, 8. Okay, great. Well, now I can make a substitution using x to just say x equals 8. And we have a sense of what that line should look like, the vertical line that all points have an x value of 8. Well, let's check that out on our graph. So if you have a graphing calculator, grab it. Let's get over into y equals mode, but make sure you're in polar mode, not function. And then you're going to make sure your format is in polar graphing coordinates. So check your format, second zoom. Once we've got that all set, when we go into y equals, we should see r equals. Go ahead and put in our function, which was 8 secant theta. Of course, we don't have a secant button, so do a fraction with 8 in the numerator and cosine in the denominator. That's the best way we can enter secant. Okay, having that, we're going to set up our window. So if you remember, your polar graphing paper goes from 0 to 360 by tens. And then we may as well just keep it simple. We have polar graphing paper that's negative 10 to 10. So let's just, negative 10 is our radius to 10. So let's just set it up as negative 10 to 10 all around, because we have a radius of 10. Now when we hit graph, we should see what we expect, which is the vertical line, 1, 2, 3, 4, 5, 6, 7, 8 at x equals 8. So let me grab that screenshot. I'm just going to paste that screenshot in here. Okay, so put that in your notes, please. The vertical line x equals 8 is equivalent to the polar equation r equals 8 secant of theta. So you should have the conversion work, and you should have the graph shown in your notes. When you're ready, hit play, and we'll move on. Okay, so I'm going to turn this one over to you. You've got your rules available still. I'm going to paste them down from prior. You've got these conversion rules. I would like you to see how far you can get with this one on your own, and then play the recording when you're ready. All right, so hopefully you were able to do some work to get this into an x or y, or a combination of x's and y format. A rectangular equation, in other words. So I'll go through this kind of quickly, because it's very similar to the previous one. We're going to first rewrite this in terms of sine, because cosecant, is the reciprocal of sine. Having done that, we're going to get it into a form that doesn't have any fractions by multiplying by sine on both sides. That's great news, because I've got something with r sine theta over here on the right side in my list of formulas. R sine theta is a y, so that's going to produce the equation y equals 7. I know you're familiar with that. That's our horizontal line that all points have a y value of 7. Let's check it out in the polar world. Over in our polar graph, let's make this 7 over the sine of theta, because that's equivalent to 7 cosecant theta. We shouldn't have to change much in our window, so let's just hit graph. Okay, so that does set up nicely. 1, 2, 3, 4, 5, 6, 7. Yep, that's the horizontal line where y equals 7. I'll put that in the notes. Great, and you should make sure you have that graph in the notes as well. Finally, now we're going to look at a polar equation that is a little more complicated. But let's get our rules one more time because they could be handy to us. Great. So accessing these rules, let's see what we can do. First off, it may occur to you to do something similar to what we did before and undo the fraction. That would be a good move. So let's do that. Let's multiply both sides by this denominator, 1 minus sine theta. Okay, that divides, and we're left with r being distributed to the terms r minus r sine theta is equal to 1. Now what? Well, I want you to scour your toolbox over here for anything that could resemble r or r sine theta that could potentially convert these polar terms into rectangular terms. And I'm sure you see it. So go ahead and make those substitutions. Okay, so hopefully you paused and made those substitutions. R, of course, is equal to the square root of x squared plus y squared. And r sine theta is just simply y. So we've done it. We've got it into a y and x rectangular equation. It's just not in a very user-friendly form right now. So let's work with it a little bit. Let's isolate the radical just like as if we were solving a radical equation. I know we haven't spent tons of work with solving radical equations recently, but we would want to isolate that first before we do any undoing of the radical. So adding y to both sides produces this equation. Squaring to undo the square root on the left side gives us the radicand. Pause and take a moment to square this binomial. That's something that, sometimes we make a mistake on. So go ahead and work that out. So hopefully you paused. If not, do it. Come on, I'm waiting for you to do it. Hopefully you paused and worked that out. It should be y squared plus 2y plus 1. That's good news because the y's add to 0 on both sides. Okay? Subtract y squared from both sides. Now I can work with this a little bit. I want to get it into a y equals form because that's what my graphing calculator will do, right? It will format in y equals or r equals. So let's subtract 1 and then just isolate y by dividing by 2. So this produces the rectangular equation y equals x squared over 2 minus half. That came out funny. Let's try again. X squared over 2 minus half. So are you familiar with that? What shape that would be that has an x squared, a y equals something with an x squared? And of course, yeah, that's a parabola. So let's check it out in polar form and see if it really makes a parabola. And sure enough, that polar equation form is exactly like what we would have expected to see if this were in rectangular form. It is a parabola. It does have a y-intercept of -half, which is what we would expect, that c value. And it opens up with a moderate amount of, I guess you would say, slope. It's not a super narrow parabola because its a value is 1 over 2. So here's the big idea that I need you to jot down in your notes. Whether you graph the rectangular equation on rectangular graph paper or the polar equation on polar graph paper, the graphs should be identical. Thanks for watching.